Greetings, my name is Hardik Raj and today we will be discussing the problem Little Elephant and Permutations. This is a cakewalk problem and there are no prerequisites. Let's move on to the problem explanation. In the problem statement, we are given an array of n integers where each integer is a number from 1 to n. First point. Second point, no two numbers are equal. So if I and j are two indexes, then a of I will not be equal to a of j if I is not equal to j. Now, so this is basically the definition of permutation. That is, each number is from 1 to n and no two numbers are equal. So let's take some examples. Example 1 of permutation can be 2, 1, 3. Here n is 3. Another example can be 1, 2, 3, 4, 5. This is a permutation in which the number of elements are 5. Another example of same length, that is for n equal to 5, can be 3, 1, 5, 2, 4. Another example can be 5, 1, 4, 3, 2. So you get the idea. This is just a permutation. Now that we have understood what the problem statement says, let's move on further to understand what exactly is an inversion count and what is a local inversion as stated in the question. Yes, there are local inversions and then there are inversions. So this inversion is nothing but the inversion count. So yeah, inversion count. If let I and j be two indices such that I is less than j, and if a of I is greater than a of j, then the pair I comma j forms an inversion pair. Let's take an example. 2, 1, 3. This is our array. And let's number them zero based indexing. Okay, so let's check all the pairs. Pair 0, 1. Here 0 is less than 1 and a of 0 which is greater than a of 1. So this is an inversion pair. This is because this is 2 and this is 1. Okay. Next 0, 2. Here a of 0 and here we have a of 2. A of 0 is 2 and a of 2 is 3. So this does not form an inversion pair because I is less than j. I is less than j. And here a of I is also less than a of j. So this does not form an inversion pair. Next pair would be 1, 2. So a of 1 and a of 2. A of 1 is 1 and a of 2 is 3. So this also does not form an inversion pair. We don't need to look for pairs where I is greater than j. Let me write it over here. We don't need to look for these types of pairs where I is greater than j because that will never form an inversion. An inversion always occurs when the left index is smaller than the right index, but the value at the left index is greater than the value of the right index. Informally speaking, a pair I comma j forms an inversion if and only if I is less than j and a of I is greater than a of j, where I and j are indexes and either 0 based or 1 based. So I will be doing 0 based. 0 is less than I is less than j is less than n. And for 1 based indexing, we can write it as 1 is less than equal to I is less than j is less than n. And in both of these cases, a of I is greater than a of j. So this is the definition of an inversion count. Now let's look at what is a local inversion. This is the definition given in the question for a local inversion. In a local inversion, if the left element, this is the left element, is greater than the right element, then it forms a local inversion. Basically, here j is nothing but I plus 1. In normal inversion count, j is greater than I, and in local inversion, j is equal to I plus 1. That is the only difference. So yeah, these are the definitions of the inversions and local inversions. Now the question asks us to find if the number of local inversions is the same as the number of inversions, and if that is the case, we output yes, otherwise we output no. So let's look at the code. For each test case, I'm calling the solve function. Inside the solve function, we have n, which is number of elements in the array. I'm doing 1 based indexing, so this array will store our array of elements from a1 to an minus 1, and all a of i's are distinct because we are given a permutation. We are defining two variables called local variables and global variables, or sorry, local inversions, in which it stores the inversion count, in which j is equal to I plus 1, and global inversions, which stores the total number of inversion count in the array. So first I am calculating local inversions. So I just need to check the adjacent character. So if the left element is greater than the right element, then this pair forms a local inversion and we increment the count. This was very simple. Now let's calculate total inversion count. So we start from 0, and should I explain this on the whiteboard? I think that would be better. So let's look at how to find the inversion count. For each I in the given array, where I is an index, for each I, we find an index j which is greater than I, such that this inequality holds. Let's do this through an example. Let's say we are given the permutation 4, 3, 2, 1, and we want to find the number of inversions, not the local inversions, the total number of inversions. So first of all, mark the indexes 0, 1, 2, 3, and for each I, we will check if we are able to find an inversion pair for this index or not. So we will take the index 0 and we will search indexes 1, 2, and 3. So if the value at index 0 will be greater than any of the values present over here, then all such j's or all such indexes will form an inversion pair with the index 0. Similarly, for index 1, we will look at indexes 2 and 3, and we will check if the value at index 1 is greater than value at index 2 or value of index 3 or not, and if it is, then it forms an inversion pair. Similarly, for index 2, we will look at index 3, and we don't need to look for index 3 because there are no more elements after that. So for this example, let's see. Okay. Yeah. So 4, and we have 3, 2, 1. We will first compare 4 with 3, and since 4 is greater than 3, this forms an inversion pair. Then we will check 4 with 2. Since 4 is greater than 2, this also forms an inversion pair. And remember, the index of 4 is smaller than the index of 3, 2, and as well as 1. And for 4, 1, this also forms an inversion pair. So we have checked all the possibilities with 4. Next, we will look at when our value of I is 0. Here I will be 1, and we will be looking at the element 3. So 3, 3, and we will check 3 with 2, and we will check 3 with 1. This also forms an inversion pair because the index of 2 is greater than the index of 3, but the value at index 1 is greater than value at index or 0, 1, 2, the value at index 2. So this forms an inversion pair. Similarly, this forms an inversion pair. Next, we will check for inversion pairs with 2. So the only candidate is 1, and since this forms an inversion, so we will also count that, and in this case the total number of inversion count is 6. Okay, but let's say we interchange 4 and 2, and a new array is 2, 3, 4, 1. So, and we need to find the number of inversion count for this array. So let's check what are the elements which form an inversion pair with element 2, or what are the indexes which form an inversion pair with the index 0. So we will check 2 with 3, we check 2 with 4, we check 2 with 1. This does not form an inversion pair, this does not form an inversion pair, but this forms an inversion pair because 2 is greater than 1. Next, we check for 3. So we check 3 with 4, and we check 3 with 1. Since the value of 3 is less than 4, this does not form an inversion pair, but this forms an inversion pair. Next, we check for inversion pairs with 4. So the only candidate is 1, and this indeed does form an inversion pair. So here the total number of inversion count is 3. Now let's move on to the code. For finding the total number of inversions or the global inversions, we pick our current I, and we iterate from I plus 1 till the end of the array, and we check if the value at index I is greater than the value of index j. In this case, pair I and j, I comma j forms an inversion pair, and we increment the global inversion count. And at the end, if the global inversion count is the same as the local inversion count, we output yes, else we output no. Let's try to submit. Okay, so the solution was accepted. And now let's move on to the time complexity. For each test case, this is a constant time operation. This is also constant time operation called n times. Okay, these are just variables. Now let's look at the local inversion count. So we are running the loop from 0 to n minus 1, and this is a constant time operation. So this basically takes O of n time to find the number of local inversions. For finding the number of global inversions or the total inversion count, what we do is we are iterating from I, and we are going to from I plus 1 till the end of the array. So this is an O of n square method, n square. So the total time complexity for each test case would be O of n for the local inversion count and O of n square for the global inversion count, which is roughly O of n square. So we are doing O of n square per test case, and the total number of test cases is t, so it will be t into n plus n squared, or we can simply say O of t into n squared. That is the final time complexity O of t into n squared. This was because n square is the dominating factor, so it doesn't matter if n is there or not. I hope you understood this solution, and see you next time. That's it for this one. Like the video if you understood the concept. In case of any doubts or queries, please feel free to drop a comment below. Do try and submit your own solution on Codechef after watching this tutorial. If you are interested in competitive programming and want to learn and master data structures and algorithms, then Codechef is a one-place destination for you. Every week we post Codechef problem explanations, frequently asked interview problems, conceptual videos on various programming topics, and also conduct live problem-solving sessions. To stay notified of our upcoming uploads, subscribe to our channel and hit the bell icon below. See you next time.